Welcome back to the deep dive, where we take the ordinary, the familiar, the things you see every day, and we slice them open to find the astonishing chaos hidden inside.
And today, the subject is something that's probably in your kitchen right now.
It almost certainly is. Today, we are sinking our teeth into the apple.
I see what you did there.
I had to. But seriously, think about it for a second. The apple it's everywhere. It's not just a piece of fruit.
Oh, not at all. It's a symbol. It's knowledge. It's health. It's temptation. It's even the logo for one of the biggest companies on earth.
Exactly. We see it constantly. But the real story of how it got here, its wild origins, its chaotic genetics, and how much it depends on us, that story is far stranger than any myth.
It really is. It's an agricultural paradox.
So that's our mission for this deep dive. We're going to extract the absolute core insights from history and botany. We want you to understand the apple's true genesis, the bizarre science that makes it so unpredictable, and the ancient human ingenuity that keeps your favorite variety alive.
Because the reality, as you said, is just so much more compelling than the stories we all think we know.
Yeah.
Most of our crops are bred for stability.
Right.
The apple, though, it sort of actively fights against that.
Mm-hmm.
It needs us. This is all about why that genetic chaos exists and how humans found a way to basically engineer a loophole to capture these perfect, fleeting accidents of nature.
Okay, let's start right there with the stories. Because before we get to the science, we have to talk about the immense cultural weight this one fruit carries.
It's loaded with symbolism. And honestly, that symbolism often gets in the way of the real history. The apple became so ingrained in Western culture that, art and literature basically created a new history for it.
And the first one, the big one, has to be the Garden of Eden. The fall of man, original sin.
Yeah.
You picture it, and there's a gleaming red apple. It's the perfect shorthand for temptation.
It is the perfect shorthand. And it's also myth number one.
Ah.
If you go back to the original biblical text, the forbidden fruit is, well, it's never named. It just says, the fruit of the tree of the knowledge of good and evil.
So it could have been anything. A fig, a pomegranate.
Could have been a fig, a grape, anything, really. The text is just not specific.
So how did the apple get the part? Why did it win this cultural casting call?
It's a fascinating mix of, I'd say, linguistic convenience and just European reality. So first, in classical Latin, the word for apple is malum.
Malum, okay.
But the Latin word malum also means evil or bad.
Wait, really? It's a homonym.
Exactly. So that subtle linguistic link was already there. The fruit of temptation was sort of primed by its own name to be associated with evil.
That's incredible. So language itself gave the apple a head start.
It really did. And then you fast forward to the Renaissance, when art is being created on a massive scale, especially in Northern and Central Europe. Artists had to paint this scene.
And they had to paint something their audience would recognize.
Precisely. They weren't surrounded by pomegranates or, exotic citrus fruits from the Middle East. They knew apples. Apples were common, they stored well, they were instantly recognizable to absolutely everyone.
So they just swapped it in. They took the linguistic hint from malum and used the most familiar fruit they had on hand.
That's the theory.
Yeah.
It was an artistic choice based on their context. And once that image, the apple as the forbidden fruit, took hold in the great paintings and sculptures and mosaics across Europe, it became fact in the popular imagination.
The cultural shift became the historical fact.
Yes. For generations who learned the story through that art, the apple was the fruit. The art rewrote the story.
I love that. It really shows how much of what we think of as history is actually shaped by, creative choices made centuries ago.
Mm.
Okay, let's tackle a second myth. This one's tied to science, but it's just as iconic. Sir Isaac Newton.
Ah, yes, the apple falling on his head.
The moment that supposedly unlocked the laws of gravity, it's always shown as this, cartoonish bonk on the head from just an apple.
It's a great story. A perfect, simple image for a huge scientific breakthrough. But even within that anecdote, the details matter. Our sources point out that it wasn't just any apple.
It had a name.
It had a name, and it had lineage.
Right.
The apple that fell, or more likely, the variety he observed falling in the orchard at his home, Woolsthorpe Manor.
Yes.
It was a specific variety known as the Flower of Kent.
The Flower of Kent. That just sounds so much more real. It grounds the story in actual agriculture, not just a fable.
It does. And the Flower of Kent is a very old English variety. It's a cooking apple, actually.
Mm-hmm.
Large, bit lumpy, green, not the kind of sweet, crisp apple you just pick and eat. You bake with it.
So it was a functional, specific product of cultivation.
A very specific one. And the incredible thing is that the original tree, or at least a clone of it, is still alive today. It wasn't some random wild tree. It was a stable variety, maintained by the very human ingenuity we're about to get into.
That's a fantastic point. Even in a story about pure physics, the object at the center of it, the apple, is already a product of human selection and technology.
Connects everything. These cultural icons, they have real genetic identities.
Okay, let's unpack this. We're forgetting the myths, we're forgetting Kent, we're forgetting the artists. Because the real ancient origin story of the apple, it starts thousands of miles away from all of this.
It really does. Our image of these neat, tidy orchards in Europe or North America, it's a historical misdirection. The true story is much wilder. It involves giant forests, rugged mountains, and bears.
Bears out. Okay, I'm hooked. So if it didn't start in Eden or an English garden, where is the apple's true home?
For that, you have to go deep into Central Asia. The ancestor of every single cultivated apple on the planet, every Gala, every Fuji, every Red Antilico, it comes from the wild mountains of what is now Kazakhstan. Specifically the Tian Shan mountain range. That is the cradle of the apple.
And what was this proto-apple? What's its name?
Its scientific name is Malus sieversia. And the amazing thing, according to the sources, is that these aren't little scraggly wild trees. They're often gigantic.
How big?
We're talking massive forest trees, sometimes towering 40, 50 feet high. And they still grow there today in protected reserves.
Wow. So the wild ancestor was already producing pretty substantial fruit. That sort of goes against the idea that wild versions of plants are always tiny and useless.
They're definitely not useless. The fruit of Malus sieversia might be a bit more bitter or astringent than what we're used to, but it's still large and fleshy. The apple was already on its way to becoming big and attractive very early in its evolution.
And the connection to the region is so deep, it's literally in the name of the place, right?
Absolutely. The former capital of Kazakhstan is a city called Almaty.
Almaty.
And Almaty translates literally to Father of Apples.
Get out, Father of Apples.
That's not just some cute marketing slogan. It's a linguistic monument.
Yeah.
It shows that people in that region have known for millennia that this was the epicenter, the original source of all apples.
That's incredible. It wasn't just a place where apples grew. It was the place, the wellspring.
The wellspring is a perfect word for it.
Yeah.
And that brings us back to why it evolved to be so big and tasty in the first place. It wasn't for us.
Right. It was for the bears?
It was for the bears. The whole evolutionary strategy, the reason the wild apple developed this large, fleshy fruit, was to attract big animals. And the main customer, so to speak, was the brown bear.
So the apple basically co-evolved to be the perfect bear snack.
Pretty much. Bears are huge, they travel long distances, and they love sweet things. They'd come along, eat the entire fruit core, seeds, everything.
And the seeds are tough enough to survive the trip through the bear's digestive system.
Exactly. They're designed for it. So the bear wanders off, sometimes for miles, and then disperses the seeds in a new location, complete with a little package of fertilizer.
That is just a stunning piece of biological engineering. The bear was the ancient shipping method. A messy, chaotic, but incredibly effective way to spread your genes far and wide.
The perfect dispersal mechanism for a rugged, mountainous landscape. And because the bears were just scattering these seeds randomly, it led to maximum genetic randomness. Every seed was a unique experiment.
And that randomness is the key to everything that comes next.
It's the key to the apple's greatest secret. Because eventually, humans started moving along those same paths, the beginnings of the Silk Road, and they started carrying these promising fruits west.
So we became the second wave of dispersers, more selective than the bears, I'd imagine.
A bit more, yes. We started bringing the DNA of Malus sieversia and all its inherent chaos to Persia, then to Greece, and eventually all over Europe. The apple hitched a ride with human civilization.
But whether it was carried by a bear or a merchant, that chaos inside the seed, that didn't change.
It never changed, and that is the deep secret we need to unpack.
Okay, so we have the geography, the father of apples in Kazakhstan, and we have the ancient delivery service, the bear. Now we get to the really interesting part, the science that dictates everything about the apple you eat today. This is where it challenges our most basic ideas about how plants work.
Right, and the secret is this, and it's fundamental. The apple absolutely refuses to grow true from seed.
Let's define that. Grow true from seed. If I plant a tomato seed, I get a tomato plant that makes more tomatoes.
Exactly. With most of our crops, especially grains or vegetables, we bred them for centuries to be stable and predictable. You plant a seed, you know what you're going to get, the apple. rebels against that. It's completely unpredictable.
Why? What makes it so rebellious?
This is the key scientific concept for our whole deep dive. Extreme heterozygosity.
Okay, that is a mouthful. Let's break that down.
It is. So when a plant reproduces sexually with a seed, that seed gets genes from both parents. In a lot of crops, like wheat, they're highly homozygous. That means their genes are very stable and similar. The offspring is basically a reliable copy of the parents.
Predictable. Good for farming.
Very predictable.
Hmm.
The apple is the polar opposite. Extreme heterozygosity means its genome is incredibly diverse, jumbled, and unstable. It's like its genetic code is a massive deck of cards that's being constantly and violently shuffled.
So when an apple tree makes a seed, it's not making a copy. It's rolling the genetic dice.
It's running a wild, random genetic experiment every single time. The baby tree will almost never be like the parent tree. It could inherit traits from a wild ancestor 10 generations back. Bitterness, tiny size, a woody texture. The good stuff gets lost in the shuffle.
So this chaos is an evolutionary feature, not a bug.
From a survival perspective, yes. Back in the mountains of Kazakhstan, with a changing climate and new pests, the best way to ensure your species survives is to have maximum adaptability. You produce 1 million random seeds, and you hope that one of them has the magic combination of genes to thrive in whatever new conditions arise. It's a long-term insurance policy.
But for a farmer who just wants a reliable crop of delicious apples, it's a nightmare.
It's a total nightmare. And this is where the lottery ticket analogy comes in. It's a perfect way to understand it.
Okay.
Imagine you eat the most perfect Honeycrisp apple. It's crisp, sweet, tart, just flawless. You think, I'll plant the seeds from this and grow my own Honeycrisp tree. After waiting 5, maybe 10 years for that tree to finally produce fruit, you will almost certainly get what apple growers call a spitter.
A spitter.
Yeah, a small, lumpy, incredibly sour apple that you'd immediately spit out. The chances of getting another Honeycrisp are, well, they're basically zero.
So planting an apple seed isn't farming, it's gambling.
You're buying a lottery ticket, and the odds are terrible. You almost always get something worthless. And this right here explains so much about early American history and the story of Johnny Appleseed.
Ah, yes. The folk hero who wandered the frontier planting apple orchards for the settlers.
That's the story we learn, but we have to ask.
What was he planting?
He was planting seeds, which means he was planting genetic chaos. He wasn't planting nice, sweet-eating apples.
So what were those apples used for?
Hard cider.
Of course.
Because of extreme heterozygosity, the apples his trees produced were mostly small, bitter, and astringent. Not good for eating, but perfect for fermenting.
Yeah.
Early settlers drank hard cider constantly. It was often safer than the water.
So Johnny Appleseed wasn't the benevolent spreader of delicious snacks. He was essentially a pioneer of the American alcohol industry.
He was ensuring a reliable source of booze for the frontier.
Yeah.
His entire enterprise was only possible because of the apple's genetic volatility. If he'd been trying to grow Fujis for people to eat fresh, he would have been a complete failure.
That completely reframes his entire story. He was working with the apple's chaotic nature, not against it.
Exactly. The modern apple, the one in the supermarket, that requires stability.
Yeah.
And the seed can never, ever provide that.
Which sets up the biggest question of all. If the seed is pure chaos, how on earth do we have thousands of stable, reliable, named varieties like Fuji and Gala and Honeycrisp all over the world?
That is where human ingenuity comes in. We solved the puzzle.
How?
With a very old, very clever piece of technology. Cloning.
Cloning. It sounds so futuristic, but you're saying it's ancient.
It predates most written history. People figured out very early on that if you find that 1 in a million tree, that perfect genetic accident, you can't rely on its seeds.
You have to find a way to copy the tree itself, asexual reproduction.
Exactly. You have to bypass sexual reproduction entirely to preserve that perfect genetic blueprint. And the technique they developed is the absolute bedrock of the entire apple industry today. It's called grafting.
Grafting. Okay, let's get into the mechanics of this. It sounds like biological surgery.
It really is.
Yeah.
So a grower finds that one perfect tree, the lottery winner. They then take a small cutting from it, just a little twig with a few dormant buds. That cutting is called the scion.
The scion. So that little piece of wood contains the exact DNA for, say, a pink lady apple.
Correct. That's the genetic blueprint for the fruit. Then they take that scion and they carefully fuse it onto the rootstock of a different tree.
A different tree.
A different tree. The rootstock is the bottom half of the roots and the base of the trunk. It's chosen for completely different reasons, not for its fruit, but for things like disease resistance, drought tolerance, or how big the final tree will get.
So you're combining two different plants into one.
You're fusing them together so they grow as one organism. The wood above the graft line is the scion, genetically a pink lady. The wood below the line is the rootstock, genetically something else entirely. And the fruit that grows will be determined only by the scion.
It's a perfect hybrid. The scion determines the fruit, the rootstock determines the hardiness and the size.
That's the genius of it. You're pairing the identity of the fruit you want with the engine you need to grow it effectively. It's how we freeze that one perfect genetic moment in time and make infinite copies.
And the scale of this is just mind-boggling. The Granny Smith apple is the perfect example, right?
The best example. It's so clear.
The green tart apple, we all know.
Every single Granny Smith tree on this planet, whether it's growing in Washington State or New Zealand or your neighbor's backyard, is a direct genetic clone of the original single seedling tree found by chance in Australia in the 1860s by a woman named Maria Ann Smith.
Wait, every single one?
Every single one. If you took a leaf from a Granny Smith tree in South Africa and one from a tree in England and ran a DNA test, they would be identical. They are the same organism, just in millions of pieces all over the world.
That's profound. So every named apple you buy is a member of a global clone army kept alive only by this human surgery.
It's the only way. The Fuji, the Gala, the Honeycrisp, they're all clones of a single original mother tree. We found a way to make those beautiful transient accidents of nature permanent.
But if they're all genetically identical, doesn't that create a huge problem, a massive vulnerability?
That is the million-dollar question. And yes, it creates an enormous risk. It's called genetic monoculture.
Monoculture.
Right.
One single genetic profile.
When you have billions of plants that are all identical clones, they all share the exact same weaknesses.
So if a new disease comes along, a new fungus or a pest that evolves to specifically attack the DNA of, say, the Gala apple,
it doesn't just kill one orchard. It has the potential to wipe out every single Gala apple tree on the entire planet. They have no genetic diversity, no varied defenses.
it's a ticking time bomb.
It's the constant, terrifying risk of clonal agriculture. We saw what happened with the Irish potato famine. They relied on one single, clonally propagated potato variety, the lumper. When blight hit, it was a catastrophe. Apple growers live with that shadow every single day.
So how do they fight that? How do they manage that risk?
It comes back to the other half of the equation, the rootstock.
Ah, the hardy base.
Exactly. All the genetic diversity we removed from the scion to get perfect fruit, we have to try to engineer back into the rootstock to get a resilient tree. Modern horticultural research is a constant arms race to breed new rootstocks that can resist the latest diseases.
So you might have a rootstock developed at Cornell University, let's say, that's resistant to fire blight.
Yes, like the Geneva series of rootstocks, which are famous for that. And you graft your fragile but delicious Honeycrisp scion onto it. The rootstock is the invisible defense system.
It's incredible. It's a constant management of two separate genetic lines fused into one tree.
And the rootstock also controls one more crucial thing we haven't really touched on: size.
Right. You said those wild Malus sieversii trees were gigantic. You can't run a modern farm with 50-foot-tall trees.
You absolutely cannot. It would be impossible to prune, spray, and harvest efficiently. So modern rootstocks are often dwarfing rootstocks. They are specifically bred to keep the final tree small and manageable.
So you can plant them much closer together.
Hundreds of trees per acre instead of dozens. It's called high-density planting. And it's all thanks to the rootstock technology that supports the ancient clonal scion on top. The modern apple is a high-tech biological machine.
It's a complete system. We essentially took a fundamentally unstable fruit, a fruit that thrives on chaos, and we forced it into a state of permanent, predictable stability.
We did. We rescued those 1 in a million lottery winners from oblivion. Without grafting, the Honeycrisp would have been a single tree that lived and died, and its seeds would have produced nothing but spitters.
Its existence would have been temporary.
Exactly. It would have been a beautiful mutation destined to vanish. We made it permanent through technology.
This has been just an absolutely fascinating deep dive. I'll never look at an apple the same way again. Let's do a quick recap of the biggest takeaways.
I think there are 3 core truths. First, the apple's symbolic power. The myths of Eden and Newton. They're modern inventions. They're built on art, on language, not on historical fact.
Right. Second, its real origin is so much wilder. It's from the mountains of Central Asia, where it evolved to be a snack for bears, ensuring its chaotic seeds were spread far and wide. The father of apples.
And third, The apple's deepest secret is that genetic chaos, that extreme heterozygosity, which means the only way we have the stable, delicious varieties we love is through human intervention cloning, the ancient technology of grafting.
It really changes how you see that fruit bowl on your counter. Each one is a clone, a
Yeah.
piece of a tree that might be centuries old, kept alive by surgery.
And that leads to a final provocative thought for you to chew on.
Mm.
Consider what it means for a fruit to exist only as a clone. That Fuji apple you bought at the store today, it's genetically the exact same organism as its ancestor from Japan 100 years ago.
It's just separated by space and time, but it's the same thing.
It is. Genetically, every Fuji tree in the world is just a branch of the original tree. It's one single plant kept alive indefinitely by us, a fragile, long-term permanence.
And if we stopped?
If we stopped grafting for just one generation, the Honeycrisp, the Gala, the Fuji, they would all vanish from the earth forever. They have a stable genetic past, but without us, they have no stable genetic future.
They depend on us completely.
They do. So think about that dependence and that strange cloned permanence the next time you bite into a perfect, crisp apple.
That is definitely something to chew on. Thank you for joining us for this deep dive into the surprisingly chaotic world of the apple. We'll see you next time.